Hi, everyone. Yeah, well, it's 2 o'clock. Welcome to this presentation as part of the Chainlink hackathon. So I'm Michi. I'm a core developer at Parity Technologies, and I will be talking a bit about Parity's Inc. It's a 101, so I will try to give you an overview over everything regarding Inc. and how you can develop it with it. And yeah, the topic of this workshop is to write smart contracts for blockchains built with Substrate. And I should probably have added Rust smart contracts because Inc is an extension of the Rust language. So Inc is a EDSL, a domain-specific Rust language for writing smart contracts. So a few words about me. That's me, as you can see in the stream. On GitHub, my handle is cmichi, and Parity uses a lot of metrics and element channels, and you can find me at Michi there in the public water cooler and all those public channels. I've been with Parity since about 3.5 years now, and Parity has for the last years focused a lot on those two technologies, so Rust and WebAssembly. Both of those are essential components to any Parity product nowadays, basically. I mean, there's a lot of front-end stuff and so on, but the top tier products, they are all written in Rust, and WebAssembly is a super essential part for everything. Parity nowadays has around 370 public repositories, so there's a lot of stuff in there nowadays. A lot of these things somehow relate to the three big pillars here now. Of course, Polkadot is the biggest thing now, with Polkadot client being written in Rust by Parity. Besides Polkadot, there's Kusama, which is a canary network for Polkadot. So it's a value-bearing live network where you can also do everything that you can do on Polkadot. But the idea is that this is kind of an early adopter, super early stage for everything. So as soon as we as developers have a good feeling about the code, and once it has gone through internal audits, everything is deployed to Kusama. And the requirement for Polkadot is that external audits are finished. So Kusama has this super bleeding edge vibe, and it's basically always only a little behind the recent master branches, whereas Polkadot, that's more like a couple weeks or months behind the last master branches. So Polkadot has more of this like sincere, super stable vibe, and Kusama is more like experimental wild cousin of Polkadot. And then Substrate is a super big thing. Substrate is a blockchain framework that we at Parity have built. Polkadot and Kusama are both written in Substrate, but that's not to say that this is the only thing you can do with it. In fact, you can use Substrate to build any blockchain. You can also build standalone blockchains. People have also built that, like blockchains that have nothing to do with Polkadot or Kusama at all. But of course, if you are targeting a parachain on Polkadot Kusama, then Substrate is like a super ideal choice. Okay, I won't go too much into detail what Substrate or Polkadot is, because 2 other people have actually given talks here at this Chainlink hackathon, and both of them are actually already on YouTube under the Chainlink channel. So if you go there, there's like 1 hour each, super nice in-depth talks about these 2 topics. But still, I want to give like a little overview to have everybody on kind of the same page here. So the idea with Polkadot is that there are different slots on this relay chain. That's how we call it. On Kusama, I'm not sure how many slots there are at the moment. I think something like 30, 40 maybe. On Polkadot, it's 15 slots, but every week new slots get added. And these slots are leases, so parachains. That's the term for a blockchain that connects to Polkadot. They can lease such a slot and have access to a lot of nice things that Polkadot gives one. For example, shared security, but also interop between the different parachains. So it's kind of like, you can pull out the best parts from other parachains and make use of them in your own parachain. But also on-chain governance and a lot of super nice features that are quite innovative and essential to any modern blockchain. Parachains on Polkadot don't have to be written in Substrate. Polkadot only has a very minimal API, but it's super handy to write them in Substrate. And as far as I know, most of them, if not all, have gone down the Substrate road. Substrate consists of a number of modules. In Substrate terminology, those are called pellets, but that's basically a synonym. And those pellets are all kinds of stuff that you would expect from a modern blockchain. So there's a pallet for assets, so fungible tokens, but also non-fungible tokens, identity, on-chain governance, all kinds of stuff. And you can basically build your own blockchain out of this Lego set of different building blocks. You can also write your own palette. And there's even one project which is kind of like there are a couple projects which are libraries for custom palettes, which teams or people out there wrote, which fit nice into this this construction set. There's also one palette for smart contracts, and that's what we are talking about today. Because if you want to write a smart contract for this particular palette, then you can do it in ink. So a question that often arises is when to write a smart contract for a parachain and when to instead go for a full-fledged parachain with its own lease on Kusama and Polkadot. And there's just different trade-offs to be made here. But basically, if you go for your own parachain, then you have only a super minimal requirement to implement a Polkadot API. And you have your fixed execution slot on Polkadot, and this is considered trusted code. So whatever you do in your slot, that's totally up to you as a blockchain. So basically, the world is open. The sky is the limit. You can implement your own economic primitives. You can implement your own governance mechanism, your own model how to charge users, all of that. There's no requirement whatsoever. If you go for a smart contract on a parachain on the other side, then that's one layer up. You basically piggyback on an existing parachain. And smart contracts are always treated as untrusted code. So that's an important thing to note. Basically, the parachain always has to make the assumption that the smart contract could be adversarial. So it has to put certain constraints into effect to make sure that the smart contract developer couldn't break the chain. And one of those big things is that this requires metering the smart contract, which is basically gas fees. So users have to pay fees for the execution time they use on the chain. So it's really like two trade-offs, and it can be kind of illustrated like this. You gain technical freedom if you do your own parachain. You can really make everything on your own. But on the other side, you have development ease. If you just develop a smart contract, then you don't have to worry about all these other things. You can just deploy a smart contract. Okay, this is a diagram that roughly illustrates how the contracts palette in Substrate works. So the contract palettes provides an API for WebAssembly blobs, so WebAssembly bytecode. And this API is anything that a modern smart contract would need in any way. So access storage, set a contract storage, who is the caller of this contract, how much value was transferred, getting random numbers, all these things. And the Vason blob, that is actually the smart contract here, this makes use of this API. So what happens if you write an ink smart contract is that it's compiled to a Vason blob that makes use of this API. And this is actually a super nice design because this whole contracts palette is completely agnostic to the language that is used on top of it. So Ink is one of the languages that you can use, but actually there are today already a couple other ones. So there's a Solidity compiler for Substrate, and there's also an assembly script, EDSL, for Substrate, in which you can write smart contracts. So yeah, it's a super nice design, because if in 10 years time somebody comes up with like a super innovative language, then as long as the language compiles to WebAssembly, you can write smart contracts for the contracts palette with it. Yeah, and actually as part of this hackathon, we also have milestones and prizes for people who add new languages for the contracts palette. This API, it nowadays has, I think, like 20 calls, but you don't have to implement all of them. So I think there are only 2 which are strictly required, and a hello world is maybe like four of them, something like that. Okay, yeah, use cases for this contracts palette. So yeah, an obvious use case is blockchains that have smart contracts as first-class citizens. So kind of like Ethereum, for example, where this is like the smart contract is the big primitive for everything. So in the Polkadot universe, those are smart contract parachains that have a unique selling point, some unique value proposition. So for example, there are parachains out there that have this idea of allocating part of the transaction fees to the developers of the smart contracts that are called. So kind of like an income for developers. So that's one of such things. So it's basically smart contracts plus something additional. And another use case is smart contracts as second-class citizens. So what I mean with that is, for example, if you have some DeFi parachain that just wants to expose certain parts of its business logic to be customizable by users, then it could use the contracts palette. So this DeFi parachain, for example, it could add the contracts palette and enable users to write trading algorithms as smart contracts as part of this contracts palette. So the main selling point, the main value proposition of the parachain would be something entirely different, implemented in Substrate with palettes, and they would add this particular palette in order to gain smart contract capabilities. And in Ink, we have a really nice integration because it's also Rust, like Substrate. So we have a nice API where you can expose certain parts of your business logic to smart contracts. Yeah, so chain extensions is the term that you should be looking for if you're interested in this. We have an example that illustrates all of this, and it's also documented. And yeah, I think it's a super nice use case because yeah, you can decide yourself what you want to make available for users to customize. And yeah, smart contracts fit very well into this primitive because it's untrusted code, and yeah, they are automatically metered and have all these safety pillars around. Another use case for the contracts palette is that you could prototype an idea that you have before going for your own parachain. So at the moment, there are a number of parachain teams that use the contracts palette, and you could just write a smart contract and deploy it somewhere there and see if it gains traction. So let's say as an MVP, you see if it works out in the real world, if there's actually use case for it. And once it gains traction and you have a community and there is a need for like higher order things like an economic model, or you want to have fine-grained control about the transaction costs, or have a governance model, yeah, then you can still transition or graduate to your own parachain, lease your own slot, and so on. But yeah, that's also a super nice use case. Yeah, if you're interested in the contracts palette, that's something I quickly wanted to show. So everything always goes back to the repositories. That's the central point for everything. And this is the Substrate repository. There's a folder frame for framework. And in there are all the standard Substrate palettes. So as you can see, there's a lot of stuff in there for all kinds of stuff, democracy and so on. And there's also a contracts folder. And in there, there's a lot of documentation on everything, how it works, how the contracts palette deals with state bloat, and like all of these things, all of these issues that are present in modern smart contract blockchains. Yeah, the other thing to highlight is the Substrate Developer Hub. If you just search for smart contracts here and this one, toolkits, then you'll find a page which has a really nice description about all the things regarding this contracts palette and the approaches it took, and yeah, stuff like that. Okay. Yeah, but let's come to the star of the show. Let's talk about Ink. So yeah, this is our project logo. We are, I think, in total, yeah, something like on the order of 8 developers. Not all of them are working on core Ink. Some of them also on like surrounded tooling and stuff. But yeah, just to give some idea. This is our mascot, this little squid. We call it Squink. And this is, so the whole idea of Ink is really that it is just Rust. That's like the core guiding principle for us behind it. So if you are a bit familiar with Rust, then yeah, I've got some code here. And you can see there's a module that is defined at the beginning. Then there is some struct definition here holding some data, in this case, just one simple Boolean. Then there's an implementation of this struct. It has a constructor where it returns the object with some default value. There's a getter, and there's also a mutable method which just flips this value. And yeah, that's how it looks in plain vanilla Rust. And in Ink, there's only a couple things that change, and those are those attributes. So this is actually a complete Ink smart contract. So you see on the top there is some attribute that annotates that this is the smart contract. And then for like the typical things that each smart contract needs, like storage, you have an annotation, and there's also an annotation which identifies the constructor and each message. Yeah, a difference to let's say competing Rust smart contract languages is that we made a choice of only exposing the stuff that is like explicitly annotated. You can't call any function of a contract if it is not explicitly annotated with either an Ink constructor or Ink message. Yeah, and let's see, I wanted to show a bit more about this because we can actually go to the Ink repository. So that's under the Parity tag organization and then just Ink. And in here, we have a lot of examples in this examples folder. And the one which I just had on the slide is called Flipper, and that's kind of our hello world. And if you look at the code here, then you will see that it's basically exactly what I just showed you. It has some more comments and stuff, but it's basically what I just showed you. If we scroll down here, then you will see that there are also some tests. This is exactly like you would do it in normal Rust. The only difference here is that we have this Ink test attribute annotation for our tests. And what this implies is that in the background, there is a mocked blockchain spawned up, so that in your tests, if you want to assert for certain things, like you want to test if your method behaves a certain way, if value is transferred, then you can just use this Ink test attribute, and you have access to a number of methods for calling mocked chain methods. Yeah, and I think that's everything for this slide. Yeah, we can also I can also show some stuff on the terminal. So I'm checking out I've checked out the Ink repository here, and I'm switching to the examples Flipper folder. And in here, I can just execute cargo build, which is the normal tooling, and you see it just builds this normal contract. And I can also use cargo test to execute the test suite. So just as you would do in normal Rust. And yeah, I mean, that's really a guiding principle for us. As you can see, like these attributes, they are really non-invasive. And this means that you can also reuse all the tooling that you already use for normal Rust development. So you can use Rust format, Clippy, but also things like your normal IDE. Like I use IntelliJ here, but you can use any other Rust compatible IDE, VS Code, whatever, Rust analyzer. So all the usual Rust tooling is available to you. Yeah. Okay, and a thing that we also have is we have a build tool called Cargo Contract. And yeah, as you saw, I can just execute normal cargo tooling here, but I can actually also execute this tool, which is our build tool for Ink contracts, and it does a bit more stuff. So the first thing that you see, it executes 5 steps, and the first step that it executes is that it checks the smart contract for some Ink-specific linting rules. So this is basically analog to what Clippy does for normal Rust code, but it's just our Ink-specific linting rules that we integrated. Yeah, so we did this in order to check if the API is used correctly, and if certain like safety issues, security issues are handled, things like that. And yeah, it's a collection that we are constantly improving on. Yeah, as a next step, the cargo project is built. And then there is some post-processing and optimization happening here. So the reason for that is that it's super important in a blockchain context that the smart contract is as small as possible. So there's a couple of things that tie back to that. One of them is that the person deploying the smart contract has to pay a certain deposit for storing it on chain. So the smaller the contract size is, the smaller the deposit the person has to pay is. The second reason is user fees, because any user that executes this smart contract has to pay fees for the execution time that the contract call occupies. So if the smart contract is smaller, this translates to less user fees. And the third point is that there is a correlation between throughput the blockchain can achieve and the contract size. Yeah, so in general, it's a super important thing to optimize towards too, and we have a lot of things that we already do in Ink to generate small WebAssembly files, and yeah, this step just does a couple more. Then we generate some metadata. I will get to that in a second. And we generate a contract bundle, and as a result, you have 3 contract artifacts here. So it's, yeah, flipper.contract is code and metadata. So code means the Vason blob. Flipper.Vason is just the pure WebAssembly blob, and then the metadata. And yeah, the cargo contract as a tool mirrors the usual behavior of cargo. So one thing that's important to realize is that you build by default the contract in debug mode. So there is certain debug information included in the contract. And if you want to build a contract for production deployment, so in order to release it, then you have to execute cargo contract build with -- release. So that's exactly the same behavior as cargo build. Yeah, and also if you execute it with -- release, you will see the optimized size goes down quite a bit. yeah, to 1.3K. Okay, yeah. So let's talk a bit about those free artifacts that are generated as part of the build process. So the first one is called the contract bundle, and the usage for that is for developer user interfaces. So I will show that in a minute, but if you, as a developer, want to deploy it and test it and so on, then that's the use case for this file. Then you have the WebAssembly file. This one is stored on-chain. So the metadata that is not stored on-chain, only this Vason blob is actually persisted on the chain. And then you have the metadata.json. This is used if you want to have like a front end or a client or a DApp that needs to know how to interact with the contract. So this is analog to what you might also know as ABI from other chains. Yeah, for people who've never heard about metadata or ABI, it's often not really clear what this is for. So this is an analog that I think illustrates it quite well. So on the left-hand side, you have the WebAssembly blob, which is just pure bytecode. And without any further information, you have no idea what all those zeros and ones in there actually mean. But if you have the metadata JSON, then you can actually make sense of this byte stream and know, for example, which methods the smart contract exposes, what the arguments are, what type of arguments you need to supply, all these things. And yeah, we can actually take a look at this. So everything is in the target link folder. And if I go in here and let's say I open the metadata, let's print it in a pretty way. Then you see that it's really just a JSON file that contains all the information that you would think should belong to a smart contract. So the compiler, a hash of the Vason blob, but also further information about the constructors that a smart contract exposes. So in our hello world, it's actually 2 constructors. There's some information about if they can receive value or not. There's also a selector in here. So this selector identifies a particular function on the smart contract and is needed if you want to call a contract function. As you see in here, the doc comments, they are also persisted. And there's some more stuff. We don't have any events here, but we have a couple of messages. And on the bottom, there's the storage layout. So in our hello world, it's just this one Boolean, which is at this position. There's also a type ID, type registry in the metadata, and you can see that it's just this primitive here. If we take a look at this contract bundle, then you will see it's actually exactly the same thing with one additional field, which is the Vason bytecode in hex. But anything besides that is just the same. Okay. So now we've compiled our own contract, and now the question is, where do we deploy it? So in general, there's different possibilities. The way how I like to do it when I develop locally is that I like to use a development node. So this is this Substrate contracts node, which we have built. So it's really just Substrate master plus the contracts palette enabled. So it's really just vanilla Substrate and the default configuration of the contracts palette. And we did some modifications to this node in order to make it super suitable for development and testing. And the main modifications are that there is no consensus. Everything is always processed immediately, but also all unstable features are enabled. Debugging is enabled by default, like all of those things that you just expect from a development environment. This node is also super suited if you are searching for something to include in your CI, for example. There's in the README there's all kinds of documentation on how to build it locally. We also have a Docker image in here, but what I would recommend is just downloading the binary release, which is available for Linux and Mac. If you're on Windows, you can just use the Docker image, and that's fine. Yeah, and starting a node is super easy. You just type this and execute a binary with --def, and you have a local node started. The other version, or the other way, is that you go via a testnet. I mean, that's super handy if you actually want to test your whole stack. You have it up or some user interface, and you want to have it live on some chain. And what we have for that is this Canvas test network, which is connected to Rococo. So Rococo is the test network for Polkadot and Kusama. There are, like, I don't know, 20 parachains connected to it, and yeah, you can use it for testing everything that you would do on Polkadot or Kusama. And yeah, as typical for testnets, you have to request some tokens from a faucet, but that's described in here. Yeah, if you have the need for more than the typical ones, like there's a daily limit, you can just ask one of us in one of the channels or create a GitHub issue, and we can figure something out. Yeah, besides those, there's also a couple community testnets. So yeah, there's no like particular preference here. I just picked them out from top of my head. So there's A-Star Scheiden, Fala, Peak, Aleph Zero. They all have like a certain unique thing to them. Like Fala does off-chain smart contracts. Aleph Zero has some zero knowledge stuff to them. A-Star and Peak, they also have different value propositions. Yeah, so you can basically choose whatever your preference is like. We also have a repository, Awesome Inc., where we collect those community testnets and other things that are worth pointing out. So yeah, feel free to create pull requests there if you have something interesting that you find. Okay, but how to actually deploy this contract bundle on our Substrate contracts node that I still have running here in the background? Yeah, there's different UIs for it. So for beginners, I think that's probably easiest is the contracts UI. So yeah, this is hosted on GitHub Pages and connects directly to this node I have running locally. And here's a tab for adding new contracts. If you click upload new contract, then you get this selection. There's already a number of accounts that the local development node that I started already provides us. They also have already endowment and things. So yeah, you can just deploy something. I'm here in the examples Flipper folder, Target Inc., and this is the bundle that we just created. And yeah, if I click next, then there's a lot of information, but yeah, most of it is not really relevant for this workshop. Only if you want to do some more advanced stuff. You can see there's a way to select a constructor. I can select some initial value, and yeah, if I go next and upload instantiate, then you see there's an event that it was instantiated successfully, and I'm on this interact tab here where I can execute the contract methods. So for get, see it's false, and if I flip it, then you can see that this actually cost me some tokens, and if I get again, it's true. Yeah, so quite simple. On the other hand, you have Polkadot.js, which is another UI that is way more advanced. So Polkadot.js really is a project that really tries to surface anything that you could possibly imagine to do. So there's everything in here, like you can handcraft RPC calls and query the chain state and stuff. So it's kind of an advanced tooling. But yeah, if I want to deploy some stuff, let's see the Flipper contract, then that's also kind of straightforward. We can also select the constructor again, deploy, and then it gets appended here. Those are some contracts I already deployed earlier. Yeah, and you can see it has a bit of a different style, like the non-mutating stuff is always displayed automatically. And if I execute something, gets displayed here. Yeah, so that's those two browser interfaces. But yeah, there's also a command line utility to do exactly the same stuff as I just did in the browser, but just on a command line. So if you execute cargo contract help here, then you will see that there are a couple of sub commands. So build is the one we used. There's also new. New just creates an Inc smart contract template, which is actually our Flipper, our hello world. So it's something to easily start out with. It has a cargo toml that is already populated with all the settings and so on. And you can just start modifying it. Besides that, there's also a couple more subcommands to interact with contracts. Yeah, so this is super nice if you want to script something locally in a shell script, or if you want to have some CI integration where you want to test for some stuff. So you can use the tool and do exactly the same things as in the UI. For documentation, there's a couple of things. So the most important thing to mention is our documentation portal. So it all ties back to the GitHub README. And in here, you can see there's a couple links, and there's the Inc documentation portal, which is this thing. And yeah, it's kind of like the manual for anything regarding Inc. And yeah, has notes on everything. You see there's a lot more attributes than just the ones I showed earlier. It also has some more detailed documentation on how to save gas fees and yeah, how to set up storage and so on. Besides that, we also have create docs. So that's the typical Rust thing. If you scroll down in the README developer documentation, then you can see there are 4 crates that we advertise here. Inc lang contains all these attributes. Inc storage, that's data structures that are available in Inc. Because yeah, actually a thing that I kind of went over is that we only use no standard in Inc. So that's something that is necessary because it excludes the Rust standard library, and the Rust standard library has stuff like hash map, B-tree map, all these things, but they are all not optimized for the highly resource-constrained blockchain environment. So what we did is that we built own data structures that are specifically geared for usage on a blockchain. And then there's IncEnv. IncEnv is basically the API you need for more interesting stuff. So there's all kinds of things here. For example, if you want to request the block number, block timestamp, who called the contract, emit an event, all those things. Yeah, and as you can see, it's just standard Rust crate docs. Yeah, Inc prelude is some stuff that would be in the Rust standard library, but since we excluded, it's not available by default. So for example, backdoor is one of those things. Yeah, so that's this here. And then we also have a beginner's workshop that is also linked in our README. It's this guided tutorial, and it's basically a tutorial how to create an ERC20 contract. Okay. Yeah, a thing that I quickly want to highlight because it oftentimes confuses developers. So in this diagram here, you see on top there's the DAP or this developer UIs, which I just showed. And for reading contract values, what they actually do is they execute a dry run of the contract. So every substrate node has an RPC endpoint, and there's an option to execute a dry run. So you can say, execute this smart contract with these values and tell me what the result would have been. And yeah, this is super essential for user interfaces, because if you want to, for example, in an ERC20, if you want to display how much balance a user has, then you don't want to issue a transaction for that, but instead you just want to have a dry run and get a result without having to pay any fees just to display this balance value. And yeah, that's how it works for user interfaces. So yeah, in our getter here. Earlier, you saw the bool which was returned, and this was actually no transaction that was issued. It was just an RPC try run. Yeah, because the thing is, if you issue a transaction, then you don't have an immediate return value. So yeah, that's the next thing. So if you, for example, want to execute this flip method, which actually mutates state and yeah, persists a side effect on chain, then you actually need to submit an extrinsic. So that's kind of like a transaction in a simplified way, also via this RPC endpoint. But this is completely fire and forget. You basically get immediate feedback that it was submitted to the transaction pool, but you don't have any return value because it's still up to the individual node when it builds the block, if it actually includes the transaction or not, and you don't have any knowledge about when this will happen. It's not synchronous. So the way how you actually get the DApp to be notified about state changes of mutations is that you have to emit an event. So in your contract, you have to use this env emit event function and yeah, emit an event, and the DApp has to actively listen for these events. So yeah, that's a typical paradigm. If you develop smart contracts, but it's something that people starting out for the first time often have a hard time grasping. Yeah, if you want to debug something, you can use anything that goes in Rust. So whatever your IDE gives you, you can set breakpoints. Yeah, anything that's that the standard Rust world provides to you. But you can also go old school, and yeah, we have a debug println macro for that. It's exactly the same as you know it from Rust. You can also use all these nice features that the Rust println stuff has. But the thing that's important here is that you have to supply these parameters to your node. So we also highlight that in the READMEs everywhere, but you won't otherwise see any debug output appear on the command line. So this is an important thing, because if this would appear by default, then any node out there, all, I don't know, 1,500 nodes or so in Polkadot would print out your debug statement. So yeah, this is an important thing to note. And the other important thing is, in order to get these debug statements, you have to execute an RPC try run. So that's the only way how they appear. So they don't appear if you execute a transaction. So only, yeah, if you use the UI, then like the Polkadot.js UI or the contracts UI, then you won't notice a difference, but it's something to keep in mind. And debug statements only appear for try runs, not for transactions. Okay, and yeah, for this particular hackathon, you probably, I don't know if you've seen this, but there's a repository under the Parity Tech organization for this hackathon. And yeah, there's a lot of further information, further like to all the documentation and so on. And there's also a challenges page in here. And yeah, there are 3 main challenge tracks for this hackathon. And yeah, one of them is ink. And yeah, there's also prize money here. Nice. And there's a couple of challenges that we've set out here. Yeah, so it's best if you read this afterwards. But basically, all of this should be documented somewhere. And if not, you can just ask us or ping us in one of the channels. Yeah, and there's all kinds of different challenges. Some of them touch Substrate as well. Some of them only ink. Some of them only the contracts palette. Yeah, so sure to check that out. Okay. And then, yeah, before we get to questions, I thought I would also highlight that we have how to contact us best. So there's public channels for Parity. Those are typically the water cooler channels. But besides that, we are always super open for issues on any of the repositories, also like just general suggestions or things that you think are not clear enough. And then a thing that we have now, since only a short time, is there is this Stack Exchange. So it's substrate.stackexchange.com. And yeah, it's a Substrate and Polkadot Stack Exchange where you can ask any questions. It doesn't have to be like super specific. It can also be more open-ended or just things that you are interested in. Yeah, and as you can see, there's an ink tag here, palette contracts tag here, and yeah, this is a community that has been quite active now. As you see, the number of users and percentage answered. Yeah, so that's actually the number one kind of support channel where you can ask anything, and can be sure that somebody will get around and reply to your things. Yeah, besides that, I should also highlight, of course, that Parity also has job openings, especially if you're enthusiastic about smart contracts and like to do these things like I just did, like giving workshops and talks. Yeah, we are especially looking for developer relations. So yeah, in case that's something that interests you, feel free to also contact me directly. My mail address was on the first slide, but I'm also in all the channels. Yeah, and now I would be open for any questions. If there are some. Yeah. Okay, yeah, so there's one question that I see here by Sacha. What are some of the main advantages of using Vason contracts over Evm contracts? Yeah, so I mean, there's a couple of advantages that stem from Rust as a language. So Rust has some inherent guarantees to prevent a couple of bugs that could otherwise occur. For example, there's built-in mutability attributes into the language, which already prevent a lot of classes of bugs that can otherwise occur. Then with Rust, you also have this thing of access to the entire Crates.io ecosystem. So you probably know this, but there's this huge community of basically Rust modules, and any module that is no standard compatible can be used in an ink smart contract. Yeah, and then there's a lot of other things. For example, you can also write parts of your contract in Solidity. If you have some legacy Solidity code base, you could deploy it with the Substrate contracts palette and write your new stuff in the cool language Rust, and yeah, deploy kind of your new components in Rust. So Vason is just a super general purpose architecture that was defined, and yeah, is surely a thing that will be staying here for a long time. And yeah, you also, if you're interested in hiring people, then you have access to the entire Rust ecosystem and not just to the Solidity hiring pool. But yeah, Vason specific more. I mean, there's a lot of languages that compile down to Vason, where Vason is also a thing that's a standard that was born out of the internet, out of a lot of internet companies, Facebook, Google, and so on. So there's a lot of industry support behind it, and we basically benefit going forward from all the innovation that goes into Vason and Vason compiler backends and all these things. So it's not just kind of a blockchain niche, but it's a big industry thing, and we automatically benefit from all of those things, all of those innovations there. And what else? I had something in mind, but now it escaped my mind. Vason was born out of these internet companies, as I said, and for websites, web applications, you have a lot of similar constraints as for blockchains. So everything also has to be super small and easy, fast to transfer, fast to execute, fast to compile, these things. So it aligns very well with the overall overarching blockchain objectives, let's say. Okay. Yeah. Then there's a question: should I go with Solidity or Rust? Yeah, of course, with Rust. There's no question about it. Especially with Ink. I mean, there's other Rust smart contract languages as well. We've also looked at them, and yeah, there's differences in design decisions that each of those projects made. Yeah, but of course, I'm most enthusiastic about Ink. Yes, and especially if you are thinking about doing more into the substrate direction, then Ink is just very well suited because it ties in very well with the whole substrate ecosystem. So, for example, if you have some smart contracts and you are thinking about later maybe graduating to a parachain, then that would be just super easy because Ink is already it's the same design primitives and stuff. Yeah. Okay, are there other questions in here?
I got a question for you. You mentioned that, yeah, you have that Solidity. You're able to write Solidity and it compiles to Wasm.
Yeah.
So does it would you write a Solidity smart contract similar to how you would write it for the EVM, or would it require its own?
Yeah. So yeah, exactly. So there's a project. It's called Solang by Hyperledger Labs. Yeah, if you type those into your favorite search engine, you will find the repository, and it's a Solidity compiler which has a couple of backends, and one of them is Substrate, another one is Solana. But basically, you can write Solidity, and you get Vason as an output. Yeah, it's under active development, so I'm not sure if they support the latest fancy Solidity features. But yeah, like the stock Solidity, you should be able to write yeah, any Solidity contract and get Vason out of it.
Wow, that's really cool. I wasn't aware of that, but I've been learning Rust, so I've been going down the Rust train myself, and yeah, I'm a pretty big fan of the language.
Yeah, it's quite nice. Yeah, we are also big fans. It's super nice to work with it, and I also like the whole tooling. Cargo Clippy, super nice, and yeah, it's also a super welcoming community, and there's still a lot going on. Yeah, a thing that I can really recommend is this newsletter, bi-weekly newsletter, This Week in Rust. I find that always super interesting to read. Yeah, for this project Solang, Parity actually has an open position for a developer who wants to work on this project because there are still a number of things that need to be implemented. So in Solidity nowadays, there's like UL, which is kind of like an assembler language in Solidity, and the support for that in Solang is not on par with like EVM compilers yet.
Awesome. I also want to say I thought it was awesome that you have that local Node Gui. I haven't seen that in any other project, and that's something really cool for beginners to get used to deploying to local nodes. That's cool.
Yeah, thanks.
Tool.
Yeah, thanks. Yeah, that's something we are trying to really put a lot of effort into to also give helpful hints. So we, like on Stack Exchange and so on, we sometimes see common misconceptions arise and stuff like that. And yeah, the UI already has a couple of hints that it displays when a certain error happens, or yeah, if you start your local node with wrong parameters, it also displays some guides about yeah, maybe you're using the wrong parameters and stuff like that.
Awesome. What are some upcoming features in Ink that you're excited about?
Yeah, so what we are looking into is we also already have that internally, but proper end-to-end testing. So kind of like, so we have off-chain testing. We have a way to mock blockchains, a blockchain in your integration tests. But what we would really like to have is like the whole end-to-end test suite automated, so that you can you're not just mocking something, but it's the proper thing. And this becomes more and more important with Polkadot, where the interoperability is like a a super important thing. Like you can basically call other chains and make use of some DeFi stuff on that chain and call some other smart contract on another chain, and kind of the sum is bigger than the individual parts, like this thinking. And yeah, for that we would like to have a really good test suite so that you can also test these more complex parachain interactions in your testing environment. But yeah, the other thing is that we are constantly working on getting our smart contracts smaller. That's a big effort, and yeah, right now there's a big effort, which, I mean, it won't really be a shiny new user feature, but it will increase our throughput and all of these kind of number KPI factors.
Yeah, so you've touched on basically improving the security and the throughput, which is, that's kind of the golden grail for the space, right? Like everyone's trying to boost those numbers. That's awesome, man.
Yeah, with throughput, we are always a bit like, we get asked about that all the time. But actually, if you look at other blockchains as well, the only not by far, not all of them are fully utilizing the throughput they could achieve. So yeah, it's we always say it's like a good problem if you actually run into this thing that your contract or your platform is so popular that you actually have throughput issues. But actually, for most of them, it won't be a problem for a long time.
Awesome. And I know a lot of people, typically they come in here and they ask for your Twitter handle. So if you can throw it in the private chat, I'll throw it up in the comments, and if people are curious, they can hit you up on Twitter.
Yeah, I've stopped using Twitter a while ago due to the overall attention span that it's grasping from you. But you can definitely hit me up on GitHub or on any of those repositories or in the public channels. And yeah, I go by Michi everywhere.
All right, yeah, I'll just throw up this handle in general, and I'll have Michi in GitHub or wherever he can be reached. Go for it.
Awesome.
All right. Well, thank you so much for that presentation. I thought it was quite informative. Great presentation, and I look forward to seeing what cool things people develop with Ink.
Yeah, thank you, Zach. Yeah, it was awesome to be here. Happy to see what people submit for the hackathon.
Great. All right. See you, everybody.
See ya. Bye-bye.